Hi everyone, and welcome back to PR Tech Talk. In the last video we got our project up and running with a web interface, but today we're taking it one step further. In this follow-up I'm adding MQTT support, and by the end of this video we'll be sending real MQTT messages straight to a Mosquitto Broker inside Home Assistant, and even control real LEDs from the Nucleo board using Node-RED. And trust me, if you ever wanted to connect your microcontroller projects to smart systems like a Pro, you do not want to miss how it all ties together at the end. So let's dive in. We continue where we left off in the last video, and that is to open the skeleton project and import that into a new blank workspace. So I go under File, Import, and choose Existing Project into Workspace and Next. There I find where I stored my zipped file from the last video, and I have it here. So the H563 skeleton YouTube zip. So we open that one, and I select the project that is in this zip file, because there can be several projects in the zip file. So we just click Finish. So here we have the project, and we can see that we have the include files on the mongoose config.h, where we have the configurations that we changed, and also if we go under source, we can see the main C files with all the changes that we did. We included the mongoose.h, and we created some two small functions there, putchar for having the print on the terminal, and the millis for the application to have a track on the time. And then we also had here down, we created the structure, and we initialized the mongoose, and we created the log that it's printing out on the printf, and we enabled the IRQ also. And then we had a management poll, so it just loops here all the time. That is where we left off. And we can just try to build a program again. So it built without any problems, and we download it to the application to the microcontroller. So then, just to verify that the project is running, we can then hit run, and we should have some logs outputting here, and we could also try to ping the board. And we will need to see that we got the 29.192.068.0.29. So we can see that we actually have a TCP/IP stack running here. Great. The first thing that I would like to change now is if we just reset this terminal here, and we clear the screen, and we start up the debug again. And I just stop it because I would like to maintain this message. We can see here that we get a message that there is a small warning. It's a weak random number generator. So it will use the function. It doesn't have any hardware random number generator to use. So it's using the software, and that is a weak one. So that's the first thing that I would like to address to improve on this project, to get a hardware random number there. So we'll take a look at that now. So to enable the hardware random number generator, we need to open the IRC file. So we click on that one. And when it has launched, we go under this security tab, open that one, go under our random number generator, and we just activate that one. That is all we need to do in this one, and we can just make the changes to the code. So it's enabled. So when we have made that changes in the CubeMX and just enable the random hardware for the RNG, we need to go under here user code begin 0 and to add a function. And this function then uses or creates a new function called mgrandom, and we then also need to go into the configuration.h file and to define that so it's using a custom random number generator there. And we try to build a project. So there was 0 errors and 1 warning, and we can now try to get that down into the code and see if we get rid of that error message. I will just bring in the terminal again. So if we now run it, and I stop it, now we can see that we don't get this message with a weak random number generator. So now we use the hardware. So that is the fix for the weak random number generator. So we will build upon this one and keep on. Great, so now we'll take the next step. So now we are going to take the next step with including also MQTT support. And I have pasted a couple of files and some information in the project, and I will go it through now. So if we start by going for the mongoose config.h, we need to then define mg enable MQTT and 1 there. So we have MQTT support. That is what we need to do in this file. In the main file we need to do something more though. First of all, we need to, under the user code begin includes, also include standard IO.h. So include standard IO.h, you need to put that there. And then under user code private defines, I prefer to do it like this because then I have all my defines easily accessible and not later down in the code. So I will have it easily accessible here. So here we have a couple of defines for the URL, and I'm running a local Mosquitto Broker on my home assistant, and I have it on this local IP address. And in my case, I need to have user and password, and so I have created a test user and a test password. So those are the ones that I have here. And then also the MQTT ID, and that is the ID for this Nucleo board, how it presents itself into the MQTT, so you can see where the data coming from. And then you have a subscription topic. You can have several subscription topics, but in this case I only have one. So I choose STM32 H563 PRTTT, RX and LED. So that is where what we subscribe, what this Nucleo board subscribes to the topic. So whenever something is publishing to this topic, it will get into this board as well. And then also it has the possibility to publish on its own, and then we have the same, but then we have an TX instead of I'm transmitting from the Nucleo board. And then just to have subtopics, that stands for 2 in this case. I don't have any function for this one yet, so you can leave without. The quality of service, I have 1, and the quality of service means one it sends at least once. And also the MQTT retain, and that is false in my case. So those, if you're interested in how MQTT works, I can do it in a coming video, or you can just Google it. Then we have some user code private variables. We have the structure there, and we have the MQTT connection there, and we have the MQTT URL, and that is the one that we had up here. Later down, I also have now put some private functions. So I just had some prototypes for the functions. So these are coming further down in the user code 0. And we will go through them one by one. So this putchar we had former, and we also had the millis, so we didn't change anything there. And earlier in this video we added this MG random, so no change there. But now the change is coming here. So whenever there is an MQTT event happening, it will come to this event handler. And I will go through the event handler and in more details shortly, but I will just go through that. And it's a quite substantial function. And then we also have a timer function. And the timer function is like this. It looks if the state for the MQTT is up and running, and if it's not, then it tries to connect to the MQTT MQTT server and the broker in this case. And that we can see in this, it uses the MQTT ID and the user and the password, and then it connects to it. And then further down we can see what else changes I did. I added this, and that is a timer, and the timer was the function that is timing out the 1000 milliseconds, so once a second. It triggers this one and see if I have lost the MQTT connection to the broker, and if I did, then it tries to reconnect to it immediately. And then I just have the polling loop here again. So if we then go back up here, so here we have that timer function that is trying to connect if I'm not having a connection. And when I do get a connection, then you get an event. And then you come up to this event handler. So then it says if it is MQTT open, the event there, that means that it has connected, but nothing else. Then it tries to subscribe. And then it puts subscribes and the topics there. And if it's not open, that means it's already open. Then it could be a message that is coming in, and then we handle the message. And if it's not a message, it could be also that we lost connection to it, and then we set the information to connection closed, and then the next second again this timer will then trigger in. I created a small flowchart to explain this function a bit more. So here I have created a somewhat flowchart of that event. So when you start from the very beginning there on the top, you have the MQTT event. So when that event is coming in, it can go three ways. Either if it's an MQTT open, and that is on the left there, as you can see. And if it's going to MQTT open, then it sends out a subscribe message to the broker what topic you would like to subscribe to. And then it just put on the UART a log, says it has subscribed and to what topic it has subscribed, and then the event is done. And then the next local or the normal way is that you get an event that is a message, and that is something or someone has published to that topic that you are subscribing to. And if you have done so, you will get an event for that, and then you go in the middle row. So then you have a message, and then we try to look into the message, and depending on the message, we will then define if we should put on an LED on or off, and which one. We have 3 LEDs to handle here. And then we publish in another topic, so we publish in a TX instead, that we are transmitting the response from the MQTT to the MQTT subscriber that the LED is now on or off. And then we also, in this event function, we also put a publish on the UART, so we can see it in the log. And in the event that we have lost communication to the broker, we will get an MQTT close. Mongoose can't see that we have a connection to to the broker any longer, and for that one we get also an event. And then we clear the MQTT connection, and we also print that out in the terminal. And then after 1 second, this timer then times out, and we try to reconnect again. And then it's all over again with the open and subscribe and so far and so forth. So I hope that explains a bit more on how that function works. So now that we have made all these changes, and I will make the file available for you, I think I will post it on the GitHub, so you will get a link in the description. And so we will try to build a project, and it built without any errors or warnings. So we try to get the software down into the microcontroller and to the Nucleo board. Okay, so now we have the Nucleo board here as well, and there we have the 3 small LEDs there. And the first one is LD1, the middle one is LD2, and the third one is LD3. And I have this USB-C connected to my computer, and through that ST-Link interface going to my computer. And then I also have the Ethernet jack just out of picture here. And these 3 LEDs, that is what we are interested in. So I have downloaded the code to the microcontroller, so we just hit run. And now let's see, I will just stop it in a second or two here. So I just stopped the code. So now we will see what happened here. So here we start. Here we have the TCP/IP, and it's up and running, and we would like to have a request for the DHCP to the server, and we got a lease, and now we have an IP number. So that is the IP number that my DHCP broker gave to my Nucleo board with the gateway and the MAC address. And then this is the IP number that is for my MQTT broker on my home assist. So this is a local IP number. And it got connected. And now let's see what we do have here more. Yep, so then when it's connected, we get this message that we have now subscribed. And we have subscribed to the topic, to the STM32 H563 PR Tech Talk RX LED. So now the board is listening to all topics, everything is happening to this one. And then there is nothing more fun too. So we do like this, we just reset it again to have it running. So now we have it running and it is connected. Great. Now we can do like this. I take an MQTT Explorer window up here, and here are the topics that my MQTT broker is currently seeing on my home assistant. And we are interested in this STM32 H563 PRTT TRX because we are sending to the microcontroller and the topic LED. So what we are going to do, we are going to turn on the first LED. So I write LED in the space, and then we write on, because the LED there is already off. So if we now publish this one, we can see that says that we have transmitted an LED, and it answered again with that it has transmitted and the LED is on there. And we can also see here now that we have the RX and the TX. So what I'm sending, that is on the RX. So that is what I'm sending. And this is what the Nucleo board is responding to. So now the LED 1 is on, so we can also turn on LED 2. And you can see here, also you see RX on and TX on. So it just responds to, and that is immediately, you can't really see, but there is some time change between them. And now we turn on the third LED. So now we have all 3 LEDs on. So this is with the MQTT Explorer, but I can also show that we can do the same thing if I'm now going into my Home Assistant, and in my Home Assistant, this is within my Home Assistant, you see it's the same IP number 242, but I have another port number. And so here I have made a small test jig, or what you want to call it, and there I have an MQTT node, and that is connected to the STM32 H563 PRTTT, RX and LED. And for that I have a couple of injectors here, so now all 3 LEDs are turned on. If I move this to there, so we can have something there. So now if I'm transmitting turn off, so now I have turned that one off, and we can turn LED 2 off if I hit the button, and the same thing with the LED 3, and we can turn them all on again. So that means that you have now full communication with the MQTT from the board, and you can also have this debug feature here. So if I enable the debug feature, we can see if I'm getting something out of it. Yep. So we are sending to the RX topic, and we are subscribing here on the TX topic. So the TX is what the STM32 H563 Nucleo board is sending to us. So when I then hit the LED 1 off, it replies with it's off as well, and the LED is turned off. Thanks for sticking to the end. Now you have the tools to create your own exciting projects and combine embedded microcontrollers with the real world. Hope you learned something and found it interesting. Please give it a big thumbs up in that case. If you have something to tell me, give it some messages in the chat below. It's really appreciated with all the comments. And if you're not a subscriber, you know what to do. See you in the next video. Cheers, bye.